I didn't finish?
I don't think so. You only did half
I only
of it.
did one of them. Now I got to do the other one too. Ah, shucks. Let's see. Well, that one is probably going to be the same thing, huh?
Yeah.
Yeah, because the other one's going to follow exactly the same sort of thing.
Or you can just multiply that one by 2. Because you know how it's symmetric.
Because it's an even function.
Yeah, I mean, it's not an even. Right? That's not a function.
Oh. Yeah.
So it would look like the answer is 0, doesn't it? But we can't say that because that formula doesn't work that way. That formula says when you are going from a finite a minus to a finite a plus. Right? Well, it doesn't say anything about when it's plus and minus infinity. So yeah, now I got to do the integral from minus infinity to 0 of x e to the minus x squared dx, which would be the limit as k approaches minus infinity, the integral from k to 0 x e to the minus x squared dx. So I guess we will do the same substitution though, won't we? Right, that substitution is going to work here as well. So this becomes the limit as k goes to negative infinity.
Negative 0 to k.
Pardon me?
You can write negative integral 0 to k.
Well, let's see. If I guess the k goes to minus infinity, now x is equal to what? To the lower limit, what's x equal to?
Oh, negative
X is k.
Negative.
X is k. When x is k, what is u?
Negative k
It's
squared.
negative k squared. And when x is 0,
0.
then we get 0. So the x dx is minus 1/2 du, and the e to the minus x squared is e to the u. So limit as k goes to negative infinity. Oh, goodness gracious. That's minus 1/2 e to the u, evaluated from minus k squared to 0. And we may as well get rid of the minus sign as we did before. So limit k goes to negative infinity, positive 1/2 e to the u, but now evaluated from 0 to minus k squared. So limit as k goes to negative infinity. And I might as well just factor the 1/2 out here. That's going to be e to the minus k squared minus e to the 0, which is 1. And yeah, that's going to turn into a minus 1/2, isn't it? So the final answer is 0. So I'm going to take 1/2 plus a minus 1/2, and we get 0. Well, goodness, that was fun. Now what are we going to do?
So what does that mean exactly? Like the area of this function is 0?
Means the area under that curve, the area bounded by that curve in the x-axis is 0.
0. So what does the curve look like? Is it just straight line on the x-axis then?
No. Something like this, approximately something like this. One of them comes out with a finite area of 1/2. And this one, since it's below the axis, this integral comes out to be the area is 1/2. But since it's below the x-axis, the integral will equal minus 1/2. So when I add the two integrals together, they cancel. Question? See, and what they're trying to get you, what they could have done is they could have given you something where this turns out to be infinity positive, and this turns out to be infinity negative. But we wouldn't add them together in that case. If that had turned out to be positive infinity, I would have been done right here. I would have said does not exist. I would have never done the second integral. The only reason I did the second integral was because the first one existed. Question?
So is that a negative area, or are we just saying that since the integral is
area
it's negative?
We're saying that the area is 1/2, but since it was below the x-axis, it comes out, the value of the integral is a negative. Question. 25 is the integral from 0 to infinity